Welcome you to the second part of the digital system design, and this is also the brief review of the content of the part 2. And in the part 2 we will study about some boolean functions. So what is the boolean function? And boolean function is the combination of the binary variable shown on the slide here, right? And this is the boolean function is about the AND operator and OR operator, yeah. And this is the true table of the boolean function. Minimize the boolean functions, we also have some definition first. First is the unity operator, and then complement, and then commutative, associative, and distribute loss. And here we extend more function. We have to remember example very important function is 10 here, right? A plus ab equal to a, right? It's very important. And yeah, and this is 12 function you have to remember. And besides, we also have another called De Morgan theorem. And this is the De Morgan. This is some kind like the multiply, and then it will divide by plus here, right? By plus here. And to prove this equation, here, this is the table to prove this equation. And we have two input A and B, right? And then we list all the possible case. We have 4 case, and then we compare of the output here and the output here, and we see that they are identical. Okay. And this is the De Morgan another theorem. This is the De Morgan 2 here, right? And this is some kind like the plus the sum, and then equal to the multiply here. And this is also the proven of the equation. Okay. And example, we apply the Boolean algebra to simplify this function, this Boolean function here. Here you can see that this is a very simple case, and you can see here, right? Just distribute everything inside. We have this one, and then we apply root 7, apply root 5, root 10, and then root 10 again, and then you will see here, and you can see that this Boolean function f1, right, it will equal to this one. They are identical. If you have time, you can create a table like previous slide, and then input the logic 0 and 1, and then check the result. This is also another example. Here I open the slide for you, and then I think that after the class you can practice by yourself. Also another, right? And we have another, we call it this is the canonical forms. It will like the sum of minterm and product of maxterm. So what is the minterm and maxterm? So this is the minterm and maxterm, the definition of minterm and maxterm. Okay, this is the minterm here, and this is the maxterm here. One thing you pay attention here is example here is 0, 0, and 0. So it will be the product of the logic, and if it is 0, and this is the complement, here. Okay, and vice versa. This is maxterm, because maxterm is the sum. So we have plus all the logic here, and 0, and this is the not complement here. Okay, this is a very important thing you have to remember here. Okay, example, I give you the an example of the truth table. A truth table on the left hand side here. Okay, example, I give you the truth table of the left hand side here, and when you look at the truth table, you have to write this f again, and this is right in the midterm form. So in the midterm form, you have to write, you have to choose the f function is one here, okay, one here, and then all f function have the result one. You sum here, example here. In this case, right, in this case one is x0, y0, and z, so this one, right, and then this is kx complement, right, and y and z complement, right, so here, right. And if you remember on the previous slide, this is, we call this m0, this is m1, right, this is m2, right. And for simplification, you just write m1 and m2 right here. And more simplify, you just write sigma here, because this is the sum. And then you can eliminate the m here, and then you have the final here. And this is the normal way they often write on the exercise. And we can write the function, this function in term of the max term, in term of the max term here. And here you can see that in the max term you will choose the result, the function is 0 here, right. Example, it is 0 here, and this will be m0, right, m capital, right, this is m3, right, and this is m4, right, this is m4. And then you write down here, and then you take the product and you simplify by pi here, pi m here, and then you can write the pi here, okay. In the boolean, in the truth table, we don't have another case we call this is don't care. So what does it mean, don't care here? Don't care here is this is the result of the function. This is the result of the function here with symbol x. So that means at this position, the result can be 0 or 1, either of them, both of them. So any of them, so we don't care. So we can write this table like in the function like this. It is similar, right, similar to previous table. So just write down here, and here you don't care here, right, don't care at the position 0, right, and don't care at the position 7. So let's just write down d here. This is the midterm, and here we choose the 0 here, right, and then we choose write is in the max term way, okay. So this is the midterm and the max term, okay. Okay, and this is another example here, right, another example of the don't care. So this is the real example, and in the real world. From the logic function we can draw the diagram again like this, right. This is very easy, just list all the symbol here, all the input here, right, and then just write down the logic. Example p complement, we will have the symbol like here p, it will become p complement, right, and then we have this logic, right, and then we just or again, and then we have x here, right. And this is similar, and this is also another symbol, and I think that this is your exercise. You can do it by yourself at home, like in the sum of product and product of sum here, right. That means in the midterm and in the max term ways, okay. This is the result, right, that is the result. Example, if I give you the weight of the signal input, and you have to write down the signal output here, okay. This is also another example, okay, another example, okay. You can practice by yourself, okay.